This is the assessment part of the module 8. So we will answer all of the 15 questions. But before we are to proceed, kindly like, share, and subscribe to my channel. Now let's have number 1. The abscissa of the point -3 and 5 is, the answer is -3. Okay, the point A is in quadrant 3. The ordinate in this point is, the answer is negative. Okay, number 3, the set of all positive input values x which produce a valid output y from function is called as the domain. So we are referring to the domain on this question. Number 4, the range in rational function is also the blank variable. So the answer is dependent variable. Now number 5, in writing the domain and range of a rational function, the format is in an interval negative infinity and 1 union 1 and positive infinity is called as interval notation. So this is called as interval notation. So number 6, in a set of ordered pairs, -5, -4, -5, 1, -2, 3, 2, 1, 2, and -4, the domain D, the answer is negative, is a set whose elements are -5, -2, and 2. You have to write only the element once. So we have two -5 here, you will write only once. So as with 2, we write only once. Okay, this is the answer, letter A. Now, in a set of ordered pairs, -5, -4, ordered pairs -5 and 1, -2 and 3. So the ranges are 1, 3, 1, -4, but you will not write twice the 1. So the answer is -4, 1, and 3. Number 8, some values for the domain of the rational function f of x equals 6x squared minus 5 equals are -2, -1, 0, 1, and 2. Find the range corresponding for its value. So here is it. So our x values or the domains are -2, -1, 0, 1, and 2. And our function is f of x equals 6x squared minus 5. All you have to do is to substitute each of these values to x. So substitute x by -2. So this is -2 squared, that's 4 times 6. 24 minus 5 equals 19. If x is equal to -1, so this is -1 squared, that's positive 1 times 6 is 6, minus 5 is 1. If this is 0, if this is x is 0, 0, so this is 6 times 0 is 0, minus 5, that's -5 here. If this is 1, 1 squared, that's 1 times 6, 6 minus 5 is 1. And if this is 2, 2 squared, 4 times 6, 24 minus 5 is 19. So these are the range values when our values of x are -2, -1, 0, 1, and 2. Now, to write in Rooster method, you have to write only once the number. So this is 19, 1, -5. And you need not to write 1 already because you had written already here. You need not to write 19 because you had written already 19. So this is the correct Rooster method of writing set of the domain. I mean the range of this function or the value of the function when our domains are -2, -1, 0, and 1 and 2. Okay, number 9, some values for the range of the rational function f of x equals 3x squared minus 5 over x are undefined, -2, and 10.75. Find the domain corresponding to its value. So here we are given a value of y, or our range values, which are -2, undefined, -2, 10.5, 10.75. Okay, now this is how you are going to solve. Since the undefined values or range value is undefined, so one value of x is equal to 0. So this, if this x is equal to 0, this made our range value undefined. So one of the value of x is 0. Now let's solve for the value of our x or our domain when our range is -2. Here is it, the solution. So substitute f of x by -2 is equal to, given function 3x squared minus 5 over x. So by cross product, you multiply -2 and x, that's -2x. And since there's no denominator of -2, so therefore just copy 3x squared minus 5 on the right side. Afterwards, transpose -2x to the right side, it becomes positive 2x squared. So here is it, 3x squared plus 2x minus 5 is equal to 0. So this is quadratic equation already. So we are to factor it out. Now, to find the factor, you have to multiply first 3 times negative 5, that's negative 15. And negative 15, the factor of negative 15, which if we combine it, the result is positive 2, is positive 5 and negative 3. So positive 5 times negative 3 then is negative 15. But when you combine 5 and positive 5 and negative 3 then is positive 2. So this is factoring by renaming. So bring down 3x squared here and use positive 5 and negative 3. Rename positive 2x by having positive 5x minus 3x. So 5 minus 3, that's 2. So the original equation does not change or will not change, is equal to 0. So afterwards, groupings. Group these two and group these two. So this would be this group plus this group. Then find out the common monomial factor of this. So it's x. So x, 3x squared divided by x, that's 3x. 5x divided by x, that's 5. So x times quantity 3x plus 5 plus the common monomial factor of this is negative 1. So negative 3x divided by negative 1, that's positive 3x. Negative 5 divided by negative 1, that's positive 5. So if you notice, we have common binomial factor of these two terms. This is the first term, this is the second term. And they have common binomial factor, which is 3x plus 5. So 3x plus 5 as their common binomial factor. So this first term divided by 23x plus 5, the remaining is x. Here is x. Then this second term divided by 3x plus 5, the answer is negative 1. So because this is cancelled. Okay, so therefore the factor of 3x squared plus 2x minus 5 equal to 0 is quantity 3x plus 5 times quantity x minus 1 is equal to 0. Equate this one into 0 and equate this one into 0 also. So 3x plus 5 equate to 0. Transpose 5 to the right side, it becomes negative 5 by multiplication property of equality, or by just simply divided by 3, divided by 3. So the answer is x is equal to negative 5 over 3. And also this one, x minus 1 equal to 0. X minus 1 equal to 0. Transpose negative 1 to the right side, it becomes positive 1. So there are two values of x when our y is negative 2. So negative 1 and positive 1 and negative 5 over 3. Now this time we are to find the value of x when our y, or the value of the function, is 10.75. So actually 10.75, when you are to change this one into fraction or mixed number, that's 10 and 3/4. So 10 and 3/4 change to improper fraction, that's 43 over 4. Here is it, 43 over 4. So this is 10.75, 43 over 4. Now equals 3x squared minus 5 over x. So find the least common denominator. So obviously it's 4x. Multiply the left side and the right side by 4x. So if this one will be multiplied by 4x, cancel 4, cancel 4. The answer is 43 times x, that's 43x. Okay, and this one times 4x, you cancel x, so you will multiply 4 times 3x squared, that's 12x squared. Then 4 times negative 5, that's negative 20. So afterwards, transpose 43x to the right side, it becomes negative 43x minus 20 is equal to 0. Okay, so you will multiply it now by factoring, by renaming. That's 12 times negative 20. 12 times negative 20 equals negative 240. Okay, negative 240. What is the factor of negative 240? Wherein if you combine their factor, is equal to negative 43. So it is negative 48 times 5, that's negative 40. When you combine these two factors, the answer is negative 43. So we are to rename negative 43x. So rename negative 43x, so bring down 12x squared. So 43x, negative 43x is actually equal to negative 48x plus 5x minus 20. So this negative 48 plus 5, the answer is negative 43. Now, groupings. Group these two and group these two. Okay, now afterwards find the common monomial factor. So it is 12x. So 12x squared divided by 12x, the answer is x. uh, minus, okay, negative 48x divided by 12x is negative 4. Plus, the common monomial factor of this is 5. So 5x divided by 5, that's x. Negative 20 divided by 5, that's negative 4. Okay, if you notice, there is the two terms have common binomial factor, which is x minus 4. So x minus 4 as the common binomial factor. So this first term divided by x minus 4, the answer is 12x. This second term divided by x minus 4, the answer is positive 5 equal to 0. Equate this one into 0. That's x minus 4 equal to 0. So x is equal to positive 4. Equate also this one into 0. 12x plus 5 equal to 0. 12x plus 5 is equal to 0. So x is equal to transpose 5 to the right side, it becomes negative 5 divided by 12, that's negative 5 over 12. Therefore the domain of the function of x equals 3x squared minus 5 over x when our given the values of our domain, or the range values of, again, the domain's values of x, or the domain value of this function given the value of the range negative 2, 10.5, and 10.75 defined. R is a set whose elements are 0, 1, 4, negative 5 over 3, and negative 5 over 12. Is there any? Okay, it's only 0, 1, 4. So this is really the complete answer. In number 10, find the domain and range of the function f of x equals 6x minus 4. Since this is a linear function, and linear function, its domain is a set of real numbers, and the range also is a set of real numbers. So the answer is letter B. Element of real. Set of x such that x is an element of real numbers, and range value is a set of y such that y is an element of real numbers. Okay, number 11. Find the domain and range of the function f of x equal to x squared minus 8x plus 15. So this is a quadratic function. We are to find the domain and range. So all you have to do is we will write here. So when we are to find out the domain of the quadratic function, is a set of x's that x is an element of real numbers. And the complicated one is the range. So to find the range, we have to solve. So f of x equal to x squared minus 8x plus 15. So our a here is positive 1, our b is negative 8, and our c is 15. So this is constant, the coefficient of the linear term, and this is the coefficient of the quadratic term. So since our a is positive 1, therefore it opens upward, and f of x has minimum value. So therefore, at the minimum value of x, or at the minimum value of the function, so let's have the vertex value, the ordinate value of the vertex, which is k, is equal to 4ac minus b squared over 4a. So for our a is 1, our c is 15, minus our b is negative 8 squared over 4 times our a is 1. So the answer is negative 1. So this is our ordinate of the vertex of the parabola, which opens upward. So therefore, this is the minimum point, minimum value of the function. Therefore, our range value is a set of y such that y is greater than or equal to negative 1. And our domain is a set of x such that x is an element of real numbers. Number 12, find the domain and range of the rational functions f of x equal to 7 plus x over x minus 5. To find the domain is to find its vertical asymptote. Equate x minus 5 equals to 0. Equate this denominator into 0. So this is x minus 5 equals 0. So x equals to 5. So vertical asymptote. Since the degree of the numerator is the same as the degree of the denominator, so therefore its horizontal asymptote is the numerical coefficient of x, which is 1, divided by numerical coefficient of x here, which is 1. So 1 divided by 1, that's positive 1. And this is the basis for our range. So this is the basis for our domain. So domain is on the interval negative infinity and 5, union 5, and positive infinity. And our range value is negative infinity and 1, union interval 1 and positive infinity. Okay, number 13, find the domain and range of rational function f of x is equal to x squared minus 4x plus 4 over x minus 2. Now, the same procedure to find the domain, equate the denominator in the 0, x minus 2 is equal to 0, so our x equals to 2. This is our vertical asymptote, the basis for our domain. Now find the range value. So to find the range, let's solve. F of x equal to, if we factor out this x squared minus 4x plus 4, it is quantity x minus 2 times quantity x minus 2 over x minus 2. You cancel out these two. So the answer is f of x equals x minus 2. Since our restricted values of x is 2, so substitute it here. If this is 2, so 2 minus 2, the answer is 0. So this is the value of, okay, f of x equal to 0. Now, our domain is on the interval negative between infinity and 2. So look at the vertical asymptote. Union 2 and positive infinity. Our range value is negative infinity and 0. Union 0 and positive infinity. Okay. Now, number 14, find the domain and range of this graph. So it's not so clear. So maybe this is 4. Our horizontal asymptote here is 4. Okay. So our vertical asymptote is 0, or the y-axis, this one. So therefore our domain is on the interval negative infinity and 0, because y-axis is our vertical asymptote. Look at the graph. It doesn't touch through the y-axis. It goes near to the y-axis, but it doesn't touch through the y-axis. So this is our vertical asymptote, the y-axis. Okay, our range value. So maybe this is 4. So the graph doesn't touch through the y-axis, the vertical, no, the horizontal asymptote, which is 4. So our range value is negative infinity, for on the interval negative infinity and 4, union 4 and positive infinity. Okay, number 5, the concentration of a drug in the bloodstream can be modeled by the function c of t is equal to 30 times t over t squared plus 9, where t ranges from 0 to 5. So determine when the maximum amount of drug is in the body. Okay, here is it. Our t is 0, 1, 2, 0 hour, 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. So what is the concentration of the blood after this time? So when it is 0, so 0. Okay. When it is 1, so all you have to do is substitute t here by 1. So 30 times 1 is 30 divided by t. 1 squared, it's 1 plus 9 is 10. So 30 divided by 10 is 3. Okay. When your t is 2, substitute this one is 2 by 2, that's 60. 2 squared is 4 plus 9, 13. 60 divided by 13, it's 4.65. If it is 3, so this is 3, this is 90. 3 squared, 9 plus 9, 18. 90 divided by 9 is 5. And 4, if our t is 4, 30 times 4 is 120. If this is 4, 16 plus 5, 25, 120 divided by 25, that's 4.8. And our t is, if our t is 5, so this is 5, 150. So this is 5, 5 squared, that's 25 plus 9, 34. 150 divided by 34 is 4.41. So which of the two ordered pairs having the greater value of the concentration of the function c of t? It's only this one. It's 5. 3 hours, the concentration of the maximum amount of drug in the body is 5 milligram per liter. So this is the answer. Letter B. Thank you.